Welcome to the premiere episode of NSCL Inside, the show where we go behind the scenes and take a closer look at Michigan State University's one and only rare isotope facility. I'm your host, Andrea Miller, and today we'll be looking at the research of nuclear chemistry graduate student Greg Pang. He's designing a device that slows down ions traveling at approximately half the speed of light and directs them to a collection point that has a diameter of less than 1 millimeter. I can't wait to find out more. Let's go look inside. So why don't you tell me what you're working on?
I'm designing a radio frequency carpet. A radio frequency carpet is a device that allows us to transport charged particles. If we creatively apply radio waves and static voltages, we can create a carpet for which the ions can walk on.
And what does an RF carpet look like?
Well, I happen to have a piece right here. Basically, it's copper metal bonded to a polyamide film. So we basically apply voltages. This creates an invisible barrier. This barrier provides a cushion for which the ions can glide on top of, while preventing any from touching the walls.
And what happens if the ions touch the walls?
If the ions touch the walls, they lose their charge, and the RF carpet can only transport charged particles, so we end up losing them, sort of like throwing a gutter ball in bowling.
When ions enter the collection chamber, they travel in all manner of directions. Those that touch the sides become uncharged and unusable and will be like, as Greg said, throwing a gutter ball. The RF carpet provides a barrier that keeps the ions from touching the side, acting like bumpers in a bowling lane, giving the ions a greater chance of reaching their target. So I see you've got some new cool glasses on, and you've taken us to another room.
That's correct. This is the detector lab. Right now, the RF carpet is just a sheet of Kapton with an interesting configuration of copper on it. To get it to work, I need to add these guys. These are surface mount resistors. They're going to allow us to provide a potential gradient on the carpet, which will guide the ions towards the collection point.
And about how many resistors do you have to attach?
Around 600.
Wow, 600. All right, I'll let you get to work. I'll check back in with you in a bit.
All right, sounds good.
All right, what have you been up to?
Well, I finished attaching on all the resistors.
So what's next?
We can measure the resistance of each of the resistors and then go test it out.
So what is this?
This is the RF carpet test chamber. It allows us to test the RF carpets before deciding upon a final design.
So can we take a look inside?
Sure. We fill the entire chamber with high purity helium gas. We apply the voltages here, and then we see if the ions are directed to the collection point down here.
Sounds good. Let's start the experiment. So we can't actually see the ions in the chamber, but Greg has created a simulation for us that lets us see what the ions are doing on the RF carpet. So Greg, what are we looking at here?
Right here is where I'm going to be starting the ions, and this strip here represents the carpet electrode surface. So we can see the impact of the RF carpet if I turn it off.
Okay, so the dot went straight into the side.
Exactly. This line here represents the path that the ion is following, and it's going straight into the carpet electrodes and is not being transported to the collection point. So let's see what happens when the RF carpet is turned on.
So in this graph, it's working because the particles don't hit the sides and they go straight for the collection point.
Exactly. It's working.
All right, so what's next?
Well, we have a couple of different designs that we want to take a look at, and once we decide on which one the best one is, for the final design, it's going to be scaled up and it's going to be installed in the new accelerator system.
So when is this all going to be done?
Hopefully soon, if I ever want to get my PhD.
Once Greg has the final design in place, the sheet will be scaled up and fitted to the actual collection chamber, which is part of the new rare isotope facility being built here. I'd like to thank Greg for showing us his research and thank you for watching. We hope to see you next time on NSCL Inside.